The last section in the chapter on conics is about translating conic sections. So when we learned about circles and parabolas, we went ahead and translated them already because circles are super easy and there's not a lot to do with them. And parabolas we'd already done before, and we just added new information to it. So this section is going to be about translating hyperbolas and ellipses. So the formula for a horizontal ellipse, when it's translated, is just the same, except we're going to change our x squared and y squared to x minus h squared and y minus k squared. The a and the b stay the same. And then just remember that your vertices and your co-vertices and your foci are always from the center. So you're always going to move those from the center, not from the origin. The same thing for our vertical ellipses. You just change that x and y to x minus h squared and y minus k squared. All the other values stay the same. You always go from the center. Alright, so writing the equation of a translated ellipse. What is the standard form equation of an ellipse with vertices at 1,6 and 116 and one focus at 114, and sketch the ellipse? So I'm going to go ahead and just make a sketch of it to begin with. So we have 1,6. I'm going to make these go by 5s. So there's one right here, and 20, and there's one right here. Okay, so what do we know about this ellipse? Well, we know we have vertices, and the vertices are the endpoints of the long side, so we know it's going to be a vertical ellipse. So we're going to use that equation, x minus h squared over b squared plus y minus k squared over a squared equals 1. So then we need to fill in our values that we don't have. So we need to find h, we need to find k, we need to find b, and we need to find a. So let's first starting to find the center. The center is going to be halfway between your vertices, so it's going to be in there. What is that point? Well, the point that's halfway between 1,6 and 116 would be the point 111, because 11 is 5 units away from 6 and 5 units away from 16. So that's going to be our center. We're going to plug this in as our h value and our k value. Okay, so we've got x minus 1 squared and y minus 11 squared. So now we need to find a and b. So a always represents the distance from the center to a vertex. So if I went from 111 up to 116, how far did I go? Well, I went 5 units. 5 squared is 25. Now, to find our b, we don't know what b is, but what other information did they give us? They gave us the focus is at 114. So that's here. So our value of c from 111 to 114 is 3 units. So we know c equals 3, we know a equals 5. We need to find what does b equal. So do you remember in an ellipse, we use that formula c squared equals a squared minus b squared. So 9 equals 25 minus b squared. If we solve for b squared, we're going to subtract 25 from both sides. We get negative 16 equals negative b squared. Let's make those both positive. Square root, square root. So we know b equals 4. And 4 squared is 16. So we put that down here. There's our equation. X minus 1 squared over 16 plus y minus 11 squared over 25 equals 1. Now we need to sketch it. So we have our vertices. We have a focus. I'll put the other focus on here. Our value of b is 4 units. So if a went up and down, then b is going to go left and right. So we're going to go left and right 4. And then we just make a smooth curve for our ellipse. Pretty much the only thing you have to remember different from this is you always go from the center. That's going to be the hardest part. Okay, and then with hyperbolas, the formulas are the same, except instead of x squared, y squared, we have x minus h squared and y minus k squared, where our center is hk. And remember, our vertices, our foci, they all go from the center, not from the origin. And there's our equation for a vertical hyperbola. Same thing, except y minus k squared goes first, and then x minus h squared. A and b still represent the same thing. Okay, so if I give you the equation, I want you to find the center, the vertices, and the foci of this hyperbola. Don't worry about finding the value of the asymptotes for this one. So to find the center, we're going to look at, this is in the form y minus k squared over a squared minus x minus h squared over b squared equals 1. So what do we know about this hyperbola? We know it's a vertical hyperbola because the x or the y squared value is first. So we need to find the center. So to find our h and k, we look at the values attached to the x and to the y. So we look at this one and this one. Make sure you always put your x value first. So your center is at the point 3, 1. Now to find your vertices, you look at your value of a. In a hyperbola, a is always the first one. This is a squared, so a is 5. So that means our value from center to a vertex is 5 units. So let me just do this really quick. 3, 1. Okay, if we know that this is a vertical hyperbola, that means we're going to go up and down from the center. So 1, 2, 3, 4, 5. So there's one vertex. What is this point? 5 units up. That's 3, 6. So we have one vertex at 3, 6. And the other one, we go down 5 units. 1, 2, 3, 4, 5. Right here. This is 3, negative 4. Okay, so there are your vertices. Then we also need to find the foci. So to find the foci, with a hyperbola, you use c squared equals a squared plus b squared. So you take these two values, these are already a and b squared, and you add them together. So 25 plus 144 is 169. Take the square root of that, and you get 13. So from the center, we're going to go up 13. So it's going to be up here, and we're going to go down 13. So down here. So from 3, 6, if you add 13, 6 plus, 3, 1 is our center. There you go. If we go up 13, that's going to be at 3, 14. And then we need to go down 13. So it's going to be 3, negative 12. Okay, so we found all the information they wanted, but we also need to sketch it. So in order to sketch it, we need to find that value of b so we can complete the box. So b is the second one. It's 12. So I'm just going to go over here, over here. Remember, make that box through the vertices. Okay, make your asymptotes. And then go from the vertex and go close to the asymptotes without touching. So there's one curve, and there's your second curve. So there's hyperbolas for you. And then to identify conic section, for this one, you're going to need to rewrite it and put it into a standard form. So what I noticed is that there's an x squared and a y squared, and they're being added together, and my coefficients in front are different. So what conic section adds x squared and y squared but has different coefficients? That would be an ellipse. So we know this has to be an ellipse. So we need to put it into standard form. So what we're going to do is we're going to put the x squared and the x together. So 4x squared minus 24x. I'm going to put the y squared and the y together. And then I'm going to subtract 9 to the other side. Okay, now in order to figure out what this value is that I need to add on to the end in order to make this a perfect square trinomial, I need to complete the square. So b over 2 squared. But before I do that, my value in front of my x squared has to be 1. So I'm going to factor a 4 out. Let's do with x squared minus 7x. Now I take that 7 over 2 and square it. That's, hold on, I did it wrong. That's a 6. There you go. 3 squared is 9. So I need to add 9 here. And remember, what we do to one side, we have to do to the other. but am I really adding just 9? I need to account for that 4. What that means is 4 times 9. So what I'm really adding is 36. So I need to add 36 to the other side. And then I have y squared plus 6y plus 9. If you complete the square, it's the same thing. So I need to add 9 here. So if I add 9, subtract 9, add 36, I'm left with 36. So this becomes 4x minus 3 squared plus y minus 3 squared equals 36. Now to put it in standard form, we have to have it equal 1. So I'm going to divide everything by 36. So that makes this become a 1 here. And then I'm going to reduce this. This becomes a 1. And this one becomes a 9. So I have x minus 3 squared over 9 plus y minus 3 squared over 36 equals 1. Now it wants us to find the center. Our center is at 3, 3. And then we need to find the foci. So to find the foci, you use c squared equals a squared minus b squared. So 36 minus 9 is 27. Yep. Which you can reduce to 3 square root of 3. So is this horizontal or is this vertical? Well, because the a squared is underneath the y, it is vertical. And we know our center is at 3, 3. Now to find our foci, we go from the center. So it has to be this one. So we go up 3, negative 3, and down 3, negative 3. 3 square root of 3. Alright, so there you go. You're done with conic sections. So make sure you do lesson 10.6 and start on your practice test. Get ready for your test. It's going to be a good one.